Quadratic equations. So quadratic equations is any equation in the form of this, right, with the highest power is x squared. When we solve these, you actually get three possibilities. You could get two solutions. Since it is x squared, you should have two solutions. You could get one solution where it's a double root, or you could get no solutions, no real solutions, where it's to get two imaginary numbers. Now there's lots of ways to solve a quadratic equation. We're going to talk about them here. There is solve by factoring. Now to do that, you need to set equal to 0 first. Now this one doesn't always work, it only works when you actually able to factor. There is solve by clipping the square. This one always works, just gets kind of ugly sometimes. There's a quadratic formula. Which also always works, but it's always about the same level of difficulty. And then there's also using technology, which we'll focus on in the next couple lessons. So there's generally 4 different ways to solve a quadratic formula. You can solve by factoring, you can complete the square, you can solve by using a quadratic formula, or you can solve by using technology. I highlight these two because these are the two that always work, no matter what. Solve by factor only works if you can factor, technology only works if you have real solutions. I guess in IB this would always work also, because in IB they tend to not give you non-real solutions. But the two that always work for sure are complete the square and quadratic formula. So we're going to go over each one. We're going to take time to go over each one. So solve by factoring. Key step here is you have to set one side equal to 0. That way you can use the null factor theorem, they call it, or the zero product property. But you have to set one side equal to 0. And once you do that, you just factor that side, and then you split and solve. So set equal to 0. Factor, kind of the important part of this, and then split and solve. So we're going to factor this first one here. Now there's only two terms, so you don't think they're crazy. Just look at what they have in common. They both have an x. So factor out the x, and you get 3x plus 5 equals 0. Right, pull out the x, what's left over? 3x plus 5. I can split it. X equals 0, 3x plus 5 equals 0. Solve this side, 3x equals negative 5, x equals negative 5/3. So there we go. This one, it does have 3 terms, so we got to set, you guess that equals 0 anyway, but it's a little more difficult. I mean, not difficult, but whatever. Set equal to 0, I always like to keep my x squared positive. It makes factoring a lot easier. So I'm going to move all this stuff over. Instead of moving this guy over there, I'm going to move both of these over here, because I want to keep my x squared positive. So x squared minus 5x minus 6 equals 0. Now we just got to factor it. It is 3 things, so we got to factor trinomial. Right, all we're really looking for is what are the factors of negative 6 that add to get me negative 5. That'd be negative 6 and 1. So x minus 6, x plus 1 equals 0. Split and solve. I get 6 and negative 1. Let's do a couple more difficult ones. So same idea, set equal to 0, but that's always step 1. So subtract 4x from both sides. You want to go down in order. So x squared minus 4x plus 1 equals 0. Now you just gotta know how to factor that. Any way you know how. Does not matter to me how you factor it. I think I generally teach you multiply the first term and last term. So you get 4x squared. Find the combination of 4x squared that gets you negative 4, which would be negative 2x and negative 2x. Those two things multiply to get positive 4x squared, but add to get negative 4x. And then what we're going to do is we're going to substitute this in for the middle. Again, this is the way I do it, just to show most people. Right, so I got rid of the negative 4x, that's what these two add. So it's this guy, minus 2x, and plus 1. So this part stayed the same. So all I'm doing is replacing the middle. Just right here. And then you can factor by grouping. These have a 2x in common, so you factor out 2x, just put 2x minus 1. You always bring down the middle sign. These have nothing in common, but you always factor out a 1 by default. And now keep in mind, if you factor out a 1, there's a negative outside. Negative 2x divided by negative 1 is a positive 2x. And positive 1 divided by negative 1 is a negative 1. Hey, these match. Do you factor that out? 2x minus 1, 2x minus 1. If you factor these out and look what's left over. So I pull those out and I got this. And look what's left over, 2x minus 1. So I get that, and then now that it's factored, you just split and solve. X equals 1/2. I said equal to 0. If I solve it, it'd be 2x equals 1. I get it twice. It's a double root, so I'm just going to write it once. You can also write it twice. But it is a double root, so the solution is just 1/2. And if you want, you can write it twice. Anyway, there's that one. And I showed you the long way of factoring, but I'll show you the way that factors. This one right here, same idea. Keep in mind, I think it's so much easier to keep your x squared positive. You always want to keep this guy positive. It makes life so much simpler. So move all this stuff over. So you can get 6x squared minus 11x minus 10 equals 0. Now again, I showed you one way to factor. There's lots of ways to factor. You could just look at the factors of 6 and 10, find a combination that gets the answer. Most of the time, it doesn't matter. Whatever works for you. So negative 60x squared. Any two things to multiply get 60. I have to get negative 10. 6 and 10 is not going to work. 30 and 2. 15 and 4. So negative 15x plus 4x. Negative 15 times 4 gets me negative 60. Negative 15 plus 4 gets me that. So remember, all I do is this. I keep the first one and the last one the same. And I replace the middle one with the combination I found. So negative 15x plus 4x. Then I factor by grouping. Which, I don't know, for me is always my favorite. So these have a 3x in common. Just divide 6 by 3x. 6x squared by 3x, you get 2x. Divide negative 15x by 3x, it's 5. We're always bringing in the middle sign. 4x minus 10. So factor out the 2. I get 2x minus 5. Those match. Pull those out and look what's left over. 3x plus 2. Set equal to 0. I thought I was done for a second. Looks like I gotta solve it. Now you split and solve. So 2x minus 5 equals 0. X equals 5/2. 3x plus 2 equals 0. 3x equals negative 2. X equals negative 2/3. So there's my two answers. It's a 5/2. Anyway, so that's how you solve by factoring. If it gets a little ugly like this, we're going to solve this the exact same way. So 3x plus 2 where x equals negative 7. So step 1, I shouldn't say it, why should I say the exact same way? Step 1, the way you solve this is you got to get rid of that x on the bottom. Because we can't factor anything with that. So all we're going to do is multiply everything by x. Alright, multiply everything by the lowest common denominator. You distribute. So you get 3x squared plus 2, because this would equal to negative 7x. Right, because x and x cancel out. So x times 3x gets me their x squared. X times 2 over x, the x is canceled, you just get 2. And then negative 7 times x equals that. Now keep in mind, since we did this, we can't get x equals 0 as a solution. If that's one of our answers, it's wrong, because I can't multiply both sides by 0. Anyway, so we have this, and we just solve it. Set equal to 0, so move this guy over. I'm going to factor. Now this one's probably one I'm just going to do the shortcut, since I know it. I'm like, okay, the 3 is a prime number, so one side has to be 3x and x. Now 2 is also a prime number, so I got to decide where 2 goes. Does it go? So it's going to be the same thing. It's going to be 2 and 1, but I got to decide where it goes. Is it going to be here or here? Is it going to be like this, or is it going to be like this? Now the thing to keep in mind is when you multiply like the outside. When you multiply the outsides times the outsides and the insides times the insides to get you the x values. So if I need to get a 7x, the 2 better become here because I need to get 6, and then I need this to be 1 to get 7. That's 2 and that's 1. Everything's a positive. So that's like another way of doing it, of factoring without having to do all the steps, but you have to really logic it out when you do it. Anyway, I just wanted to show you a different version. Anyway, and now split and solve. So here I'd get 3x plus 1 equals 0. X plus 2 equals 0. X equals negative 1/3. X equals negative 2. So yeah, this one I showed you a slightly different way of factoring it. Again, you can do it any way you want. And I didn't get 0 as an answer, so I'm good. This one I want to show you, right? you don't, it's not equal to 0, so you can't split it. Doing this and this 16 is so wrong. It doesn't work. Because if you did solve one of these, if I saw this and I got x equals 20, if you plug it back in and try to make it work, it's not going to work. So if I plug in 20 for these, I get 16 here, which is good, so what I kind of want. But over here you get 22. 16 times 22 doesn't equal 16. The reason the zero product property works is that once it equals 0, once you get one side to be 0, it works. It's true. 0 times anything is 0, so it always works. So again, watch out. Don't just split it and be lazy. It has to equal 0 first. So how do I do this one? Well, I got to simplify. So let's distribute. Because I got to set equal to 0. So I got to move this guy over. But I have this now. So I'm going to have to simplify this so I could figure out what my equation is. So we're going to distribute this real quick. X squared plus 2x. And this negative 4x minus 8 minus 16. So then this simplified a bit. X squared negative 2x negative 24 equals 0. And then I could factor. It's an easy factor. Two things to multiply, get 24 back to get 6. The negative 2 is x minus 6 and x plus 4. Right, negative 6 times 4 is negative 24, but when you add them, you get the middle sign. Now keep in mind, when it's a negative, you know it's going to be plus and minus. Whatever the middle sign is the bigger number. So this one, my middle sign was a negative, so I knew 6 was going to be a negative. Anyway, from there you split and solve x equals 6 and negative 4. So that's how you solve by factoring. You have to set equal to 0, very important, and then factor. Factor any way you want. So this is a basic factoring. This one I did kind of like a logic-based one, and then this one I did the thing where I multiply the first term and last term and I factor by grouping. But you can do it any way you want. Next, we're going to solve by completing the square. Now, remember from earlier, I said completing square is one of the ones that always works. This and quadratic formula always work. Because not everything can be factored. But you can always complete the square and you can always use the quadratic formula. Now again, completing the square won't always be pretty, but it will always work. So let's talk about how to complete the square. So there's the easier version, there's like the slightly more advanced version. The slightly more advanced version is when you have a coefficient in front of your x. So we're going to do the easier version first. And the general idea of completing the square is you want to get ax plus bx alone. So isolate ax squared plus, well for us we're doing the easy version, it would be x squared plus bx. We'll see to the other side. And then we're going to do what I call complete the square step. We're going to complete the square, which is where you add the coefficient of x, b, divided by 2, square to both sides. You add this guy to both sides. So that's when you complete the square. That's the square part. And once you do that, you want to factor the left-hand side and then solve. So those are my 4 steps to complete the square. So again, this is one more basic when there's no number in front. So first step here is we're going to isolate x squared plus 4x. So remove move that negative one over. So I get x squared plus 4x equals negative 1. And then we're going to complete the square step where you just get the middle term, the linear term, divide that by 2 and square it. So this would be 2 squared, which is 4. And then we're going to add that to both sides. So add it here and here. So after we do that, we're just going to simplify the right-hand side, and then we're going to factor the left-hand side. This side factors, and it factors perfectly, so we did with the square. But my hint always, the factor of this is always the thing before you square it. The factor of it's always this. It's always b over 2. So that's what it factors. So in this case, it's x plus 2 squared. Because it's a perfect square. It's like that every single time, because you're creating a perfect square. So you get the middle term, divide by 2 and square it. You get 4, add it to both sides. You factor the side. It's always a perfect square. It's always the thing before you factor. The thing before you square. And then from here, we did this earlier. You just solve it. Square root both sides. When you do that, you get x plus 2 equals plus and minus rad 3. Can't do anything about that. Now we're subtract 2 from both sides. X equals negative 2 plus or minus rad 3. So there you go. So that's how you solve a basic complete the square problem. Now let's go a little more advanced. Now the advanced one has a number in front of the x squared, so it's a little different. So step 1 still being the same. We're going to isolate ax squared plus b x. So that's still going to be true. So I'm going to get rid of this 5. Move that 5 to the other side. So negative 3x squared plus 12x equals negative 5. Now part 2 is a new step. Just like before, I want to complete the square. I want to add this b squared over this b over 2 squared to both sides. But it only works when it looks like this. When it's a 1 in front of the x squared. It doesn't work otherwise. So to make this a 1 right here, we got to factor out an a. We got to factor out a from the left hand side. So I can't have this negative 3 right there. So what we're going to do is, you could do 2 things. You could divide everything by negative 3. Sometimes it gets a little ugly and you don't always want to do that in the future. So what we're going to do instead is we're just going to factor this negative 3 out of the left hand side. So it's something like this. Negative 3 x squared. If you have 12 divided by negative 3, you get negative 4 x. And the side stays the same. Alright, so we factor out the a from both sides because we want to make this a single, just a 1 in front of the x squared, because that's when we can do the complete the square step. And that's our next step, complete the square. So we're going to get the middle, we're going to get the linear term divided by 2 and square it. I'm going to add that to both sides. Now in this part, you got to watch out. I'll explain why in a second. So we're going to get the linear term right here. Negative 4, we're going to divide that by 2 and square it. So I get negative 2 squared, which is 4. Now we want to add it here and here. So I add 4 here. Now on this side, I'm not gonna add 4. I'm actually add more, because when I added 4 to this side, everything in this parentheses here gets multiplied by negative 3. So that's what I got to add at this side. So I could add 4 times negative 3, because that's what this value I add on this side. You add 4 here, but it all gets multiplied by negative 3. So you're actually adding 4 times negative 3 to this side, which is negative 12. So that's the part you got to watch out for. Other than that, the rest of it's the same. Factor the left hand side and solve. So remember the way you factor this? It's always the thing before you square it. So this is going to be x minus 2 squared. So negative 3 in front. The right hand side, you just simplify negative 5 plus negative 17. Negative 2 is negative 17. And then we solve. Divide by negative 3 first. That's the first thing we do. And we want to get rid of the, you want to isolate the x. So you get rid of the outside first, and then we're going to get rid of the square. It's not looking pretty, but it will work. As I said, complete the square is not always pretty. So we have that. Negative 17 divided by negative 3 is this. And then we're going to square root both sides. So I get x minus 2 equals plus and minus radical 17 over 3. I'm going to leave it like that. And just add the 2 over. And there's our answer. So that's how you complete the square. Right? The general idea is you want to isolate anything with the variable to square it in the linear term. And then you complete the square by adding the linear term divided by 2 squared to both sides, and then you factor the left hand side and you solve. It's a little more complicated when there's the a in front, but this means you have to factor out the a in the second step. Anyway, let's move on to quadratic formula, which is for most people their favorite one, because like here's the formula, plug it in, and it works. The key thing to that though is, much like factoring, you got to set equal to 0 first. So don't forget that step. You do have to set equal to 0 first. Actually, what most people do is when they see a quadratic, they set equal to 0 first, and then they do try to factor to see if it factors. And if that doesn't work, then they do the quadratic formula. That's like the backup plan. Because factoring is the fastest if it works. Quadratic formula could be a little janky if the numbers are big, but generally okay. By the way, where does this formula come from? It comes from completing the square. You get a generic quadratic equation like that, standard form, set equal to 0, and we complete the square. Now, in this case, discriminating square, just divide everything by a, because remember you can't have a coefficient in front. And then we isolate this side. So that's what they did here. You can see they isolated anything with the x's. And then they completed the square step, right? They added the linear term divided by 2 and squared. So you got this divided by 2 and squared it. And they added that to both sides. And then they just solved it. They're like, okay. Actually, they factored the left-hand side and you got this. As I said, right, it's always the thing before you square it, it's that. And then they square root both sides, and they get x by itself. And you get the quadratic formula. So that's where it comes from. So it didn't magically pop up. What they did is they completed the square on the standard form. Anyway, so we're going to solve these by quadratic formula. So let's do it real quick. Quadratic formula is on your formula sheet, so you don't have to memorize it. You know, we should all have it memorized by now. So negative b plus or minus square root of b squared minus 4ac all over 2a. So if I was going to do on the first one here, now remember, so a is the coefficient of the x squared, so in this case it's 1. B is the coefficient of the linear term, so negative 2. And c is the constant term, negative 6. And then we substitute into the formula, so x equals negative 2 plus or minus square root of negative 2 squared minus 4 times 1 times negative 6 all over 2 times 1. A couple things to watch out for. Specifically right here, negative 2 squared is probably where most people go wrong. You know what negative 2 squared is, right? This is the thing where it's inside the parentheses. So negative 2 squared is a positive 4. This should always lead to a positive number because you're squaring something. You're squaring the whole little thing there. And then here, negative 4 times negative 6 is positive 24. Double negative here makes a positive 4. And keep in mind this thing's on the bottom here is divided. It's underneath both of them. So I get 4 plus or minus radical 28 over 2. Radical 28, I should try to break it down. So 28 is what? 2 and 14, 2 and 7. So it actually does break down a pair of 2's. So it's 2 rad 7. So I'm going to rewrite that. So I get that. And honestly, I should be able to divide everything by 2. So I could just get 2 plus or minus rad 7. Now again, if it's on the IB exam takes this as full credit. You don't have to go, unless they specifically tell you, like, make it look like this. If they're like, make it look like this, then you got to go all the way down to it looks something like that. But if they don't say that, this is totally fine for the IB exam. Now we're going to skip the other example because it's more of the same. Quadratic formula is pretty straightforward. Set equal to 0 and plug it in, you got your answer. But let's talk about some of the consequences of it. So the discriminant of the quadratic formula. The discriminant is something that is again on your formula sheet. It is this guy right here. The discriminant is delta. That's our logo for discriminant. It's a triangle, better triangle than mine. B squared minus 4ac. Now that b squared minus 4ac should ring a bell. That's a quadratic formula, right? This right here is a discriminant, and and what we're going to use that for is when you do the quadratic formula, this kind of tells you how many answers you have. If that guy right there, right, for my discriminant, see how it's right here? Right here, how it's the thing underneath the radical. If that guy is positive, that means I'm going to get 2 real solutions like we did right here. I get a nice answer, and I get 2 of them. So it's 2 real roots. We'll call that. Solutions do the same thing. Basically, your graph looks like this. Alright, where you get 2 solutions. X-intercepts, also known as zeros, also known as real roots, all the same thing. So when the discriminant thing underneath the radical, right, is positive, you should get 2 solutions, or 2 x-intercepts. What happens when the thing underneath the radical is 0, though? Right, what happens if this is a 0? Well, then you get something like this. Negative plus or minus rad 0 over 2a. Well, that just goes away. You just get 1 solution. So 1 real root. So that's a graph that looks like this. It's a graph at 1 spot, and we call that a double root because it bounces. So it's the same answer just twice. So if your discriminant is positive, that means you're going to get a plus and minus, so you get 2 real roots. If your discriminant is 0, that means it's kind of just cancels out. You just get the 1 answer, 1 real root to double root. And then lastly, what if the discriminant's negative? Then you get 0 real roots, because if it's negative, you have a square root of a negative number, and that's imaginary. As we talked about before, IB really doesn't do imaginary. It wants you to know that, these things are unreal, but they really don't have i's. They don't deal with i's. That graph of that would look like this. So you have no x-intercepts. Because x-intercepts are roots. Or real roots. So those are your three things. So if we just look at the discriminant, I could tell you what type of solutions I'm going to have. I'm going to have 2 real solutions, I'm going to have 1 real solution, I'm going to have 0 real solutions. So that's what the discriminant tells you. Because it's the thing underneath the radical. It gives you all that information. So with that in mind, we're going to use the discriminant to determine the nature of roots. Do we have 2 real roots, do we have 1, or do we have 0? So all we have to do here is use the discriminant formula, which again is in your formula sheet, which is this guy, b squared minus 4ac. And honestly, you shouldn't need it on your formula sheet. It's a quadratic formula. It's that part underneath the radical. So all we do is substitute into there and then see what we get. So again, my a is the thing of the square term, b is the coefficient of the linear term, and then c is a constant. So my discriminant here is going to be negative 2 squared minus 4 times 2 times 3. Again, the negative is inside the square, so when you square, you just get positive 4. Minus 8 times 3 is 24, so I get negative 20. So this means I have 0 real roots. If we were going to try to solve for something, I can write that. There you go. If I was going to try to solve this with a quadratic formula, I would get no solution. Because I would get no real solution. Same thing over here. Let's do one more so we can practice. I just want to figure out how many roots do I have. Do I have 0, 1, or 2? Now again, I did say this is in your formula sheet. It does give you the discriminant. It does not give you this part though. This part you have to know yourself. And again, to me it's not that bad. You just gotta understand it's something underneath the radical. So if you get a positive, you get plus and minus. So 2. If you get 0, it cancels, so you just get the 1 answer. And if it's negative, we'll give a square root of negative, so you get no real solutions. So like this, you have to know yourself. The actual formula they give to you. So we're gonna do the same thing here. My a would be there, my b would be there, my c is there. So this guy be negative 4 squared minus 3 times negative 2. So 16 plus 6. So, I mean, that's the part I don't need to add and get 22. I already know it's positive. So it's 2 real roots. Like that. And okay, last thing. Sometimes they'll give you something that's a little more conceptual. So, but look at the question here. Consider x squared minus 2x plus m equals 0. Find the discriminant and hence find the values of m for which the equation has a repeated root, 2 distinct roots, or no real roots. So the key to this is, well, first, anytime we talk about roots or number of roots or number of solutions, you want to think discriminant. Now this one strictly tells you discriminant, but even sometimes they don't. They're just like, hey, does this have 1 real solution or does it have 2 real solutions? They want you to use a discriminant. So write our discriminant to this. And what we should know is if it's a repeated root, that's the same thing as saying you have 1 root, because it's the same one repeated. So that's when the discriminant equals 0. If it's 2 distinct roots, that's when the discriminant is greater than 0, and then no real roots is when the discriminant is less than 0. So all we gotta do is set up that equation. So the first one here, I want the discriminant to be equal to 0. Remember, my a is the coefficient of the x squared. My b is the coefficient of the linear term, and my c is the constant term, which in this case is m. So we're just going to plug it into the equation. So I'm going to get negative 2 squared minus 4 times 1 times m. And again, since this one says a repeated root or double root, which just means you have 1 root because it's the same root twice, you set it equal to 0. That's how the discriminant equals 0 when you have 1 root. And then all you have to do is solve this. So 4 minus 4m equals 0. Add the 4m over and divide by 4. M equals 1. So in this equation, if you want a repeated root, m has to be 1. And we're going to carry on with the rest of it. If I want to have 2 distinct roots, we're going to do the exact same thing, the exact same formula. But now, since I want 2 repeated roots, I'm going to set it greater than 0. Because I need the discriminant to be positive to hit 2 repeated roots. Then we just solve it. In this case, I'm going to subtract 4x from both sides because I like to keep when we're doing inequalities, I like to keep the variable on the left hand side. I'm going to divide by negative 4. Remember, when you divide by negative, it flips the inequality. When you multiply, divide by negative, it flips the inequality. And I get this. M should be less than 1 if I want 2 distinct roots. And then finally, if I want no real roots, So I want my thing to be negative. I'm gonna start. I would start from this spot here. 4 minus 4m. I want that to be less than 0. It's gonna be the same thing. Subtract the 4 from both sides. Negative 4m is less than negative 4. Divide by negative 4, which flips the inequality. So m is gonna be greater than 1. This is actually a question that IB likes to ask a lot. They'll bring up discriminant. It's like in lots of places. So remember the key is understanding the discriminant itself, like the formula they give to you in the formula sheet. That's in there. But you understand that if they say this thing has a repeated root or a double root, that means it should equal 1 because you only have one solution. So C equals 0 because that's the way you get one solution. If it says it has 2 real roots or 2 distinct roots, then it has to be greater than 0 because you get the plus and minus. And if it says it has no real roots, that means it has to be less than 0 because that'll get to the square root of a negative. Anyway, that's the idea.